Okay, in this video I want to try to tie together the remainder theorem and the factor theorem for you guys. So to remind you of the remainder theorem, it's telling you when you've got a polynomial function f and you've got any real number c, and the number f of c, in other words, what number you get when you plug c into your function, that's the same thing as the remainder when you do f of x divided by x minus c. The factor theorem says, down below, if you've got a polynomial f of x and you've got a real number c, number one, if x minus c is a factor of f, then f of x divided by x minus c has no remainder, as remainder 0 is another way to say that. And number two, you could read that backwards. If the remainder when you divide is 0, then x minus c has to be a factor of f. Now, the new stuff. What are some consequences about both of these? If you know any one of the following, then in fact you know all of the following. So, saying that x equals c is a 0 or a root of f of x, now maybe we haven't encountered that language before. All that means is that when you plug c into your function, you get 0. In other words, f of c equals 0. So if you know that c is a number that makes your function 0, that's the same thing as saying that c comma 0, looking at number 2 now, c comma 0 is an x-intercept for your graph. And that's the same thing as saying that x minus c is a factor of your function f. So what your task is to be able to kind of fluidly, use any one of these three as necessary. They all tell you the same information. So when you know one, in fact, you know them all. So to give you an example of maybe what I mean by that, if we look at this function, f of x equals x minus 2 times x minus 1 times x plus 3, maybe you're asked to find the roots or the zeros of this. So to do that in general, what you're always supposed to do is, well, take your function and make it equal 0. And so that's what we'll do. And then we're supposed to just solve the resulting equation that we get. And then what do we know? Well, if three things multiply to give you 0, then you should just set each one individually equal to 0. So the first one tells you that x equals 2. The second one tells you x equals 1. And the last one tells you that x should be negative 3. Now all I'm saying is we're going to name those. We're going to call those the roots of this function f. So the roots are x equals 2, x equals 1, and x equals negative 3. So now you know number 1 above in this consequence I was referring to. And all I'm trying to tell you is that you could also translate this to say that 2 comma 0 is an x-intercept, that 1 comma 0 is an x-intercept, and that negative 3 comma 0 is an x-intercept. And then also what you need to know is that that stuff tells you that x minus 2 should be a factor of your function, which it is. It's how it's given to you. Similarly, x minus 1 should show up as a factor, and x plus 3 should show up as a factor of your function. So all three of these things are information that you know.